Hi, welcome to the Renogy video series. Today we will be discussing how to use the various calculators that we supply our customers with so that you can get a better idea of the different characteristics of your potential solar system. The first step to take is to navigate to our calculator page. Start your internet browser of choice and then load our web page, renogy-store.com. Once our page loads up, click on the Design button located on the lower title bar, which will load the calculator selection page. You will now be faced with a calculator type choice. We'll walk you through both types and their various uses, but we'll initially focus on the solar calculator type located on the left side of the page. Go ahead and click here. Once you open our solar calculator, you'll see it divided into two sections, one on top and the other below. The top portion deals with grid tie or on-grid systems, while the lower calculator is used for off-grid. On-grid systems are those tied to the electrical grid and are typically used for residences, while off-grid systems are typically used for separating a residence from the power grid or for connecting to an RV. There are many other differences and applications between these systems that we will explain in an upcoming video. If you are unsure of what you want, feel free to contact our offices via telephone or on the web and we can help you decide. For the first part of the video, we'll focus on on-grid applications. Before getting started with either type of calculation, one of the most important pieces of information is the amount of average peak insolation or average peak sun hours that is available at your location. This can be a complex topic, and we urge you to check out more of our future videos for a detailed explanation on the topic. Renogy offers tabulated insolation data for U.S. locations. This table is located in a link at the bottom of the solar calculator page. In it, you will see a range of values for most states. The lower values represent the lower averages, and likewise the larger values represent the higher averages. Please note that some states simply don't vary much throughout the year and therefore only have a single value for the average. The higher and lower averages correspond to differences in insolation according to the seasons. You can use any value between these numbers in the calculator for estimating, but we recommend using the lowest available value so that you are planning your system for the worst case scenario. Since we are located in Chino, California, I'll be using the California values throughout this video. As you can see, California receives 5 to 7.5 peak sun hours a day. Focusing back on the calculator, let's do an on-grid calculation. For this type of calculation, you'll need to have an electrical bill handy. Here we have a sample bill from our office. If we look at the section of the bill titled Usage Comparison, we can see our consumption each month. This value is reported in kWh, which stands for kilowatt hours. This is a measure of electrical energy usage. The best way to use the calculator is to take an average of these values, which would best represent your monthly usage. To do this, add up the total usage for the months and then divide by the number of months. For our case here at the office, adding all these up comes to a total of 7,415 kilowatt hours over an 8-month period. Dividing this by the 8-month period will give us the average monthly usage of around 930 kilowatt hours. Take this value that you've just calculated and plug it into the calculator as an answer to the first question. Secondly, decide how much of your consumption you wish to be powered via solar. We typically recommend the percentage to be somewhere below 50%. Systems above this percentage typically result in difficult projects due to their expensive nature and the system size. System sizes tending toward 100% are usually very large, and most customers in residential areas do not have the real estate to accommodate them. We'll play with this value later to show you the difference. For starters, we'll use 50%. Lastly, fill in the box for your average peak sun hours that you looked up in the table. Remember, for us at the office, this range was 5 to 7.5 hours. I'll use 6.25 hours here to represent a nice average throughout the year. Now that we have all of our values, we'll click Calculate. The calculator will then give us two values. The minimum system size represents the absolute minimum to meet our system needs. The recommended system size is simply a 15% oversize to compensate for bad weather and other factors that could pull system performance down. For us, this recommended system size is 2,850 watts, which is decent sized. From here, you can play with the percentage solar by changing the percentages value and clicking Calculate again. For us, choosing 30% shows a system size drop to 1700 watts, while a 100% change will result in a 5700 watt system. As you can see, 100% size systems can be quite large and expensive. In fact, our largest sized pre-packaged grid tie kit wouldn't be big enough for our calculated usage. Although it would still be possible to do so, it would be fairly costly and take up a large amount of space. Now let's take a look at off-grid systems. Off-grid systems can be quite complex when it comes to determining a system size. There are multiple ways to approach the problem depending on what your goals are for the system, and there's also more variables to consider with respect to specifying the system components. Therefore, please use the results from this section as a way to get a ballpark figure for your needs. First, you will need to determine the total wattage that the devices you plan to connect to the system will consume. This information can usually be found on an appliance label. Take a look at this refrigerator label, for example. This refrigerator does not have the energy rating directly in watts, but it does give us the amperage and voltage. Multiplying these two numbers together, 1.5 amps and 115 volts, gives us 172.5, which is the wattage that it consumes. Note that some devices like a refrigerator have a startup amperage, which should not be used for these calculations. Another example is this microwave label. This label gives you the wattage consumed directly, which is 1050 watts. Once you've gathered all of your wattage values for your appliances, go ahead and add them up for the total wattage. The next thing you need to consider is how long you plan to run these devices for. For example, how long would you expect to watch your television at night? Note that this calculator only considers your total required wattage, so if you plan to run different devices for different amounts of time, run the calculator for each device separately. For example, if you have a water pump that only turns on a few times a day for a few minutes at a time, you wouldn't want to include that in the total wattage, or the calculator will think that the pump is running for the same amount of time as everything else is. Next, consider the charge controller efficiency of the system. Different charge controller types will have different efficiencies and will affect how much power you can actually draw from your system. If you are new to solar and are unsure of which controller type you wish to have, we recommend using the figure for PWM type, which is 80%. This is because typically our first-time consumer will purchase a kit with this type of controller. We recommend that you use the percentages indicated on the web page unless you know that a particular charge controller you plan on purchasing has a different efficiency. For more information on charge controllers, keep up with our video series or contact us and we'll give you some more information regarding them. Lastly, determine your location's average peak sun hours from the chart we showed earlier. For off-grid calculations, we highly recommend using the lowest value possible for your location due to the fact that users of off-grid systems may not have another power source available, and this lowest value will help you compensate for the worst-case scenario with respect to solar conditions. Once you've gathered all the necessary information for the calculator, go ahead and enter the values in the calculator. For our example, we'll be drawing 300 watts from the system and running that load for 3.5 hours. We'll also use a PWM charge controller with this system for an efficiency of 80%. For our sun hours, recall that California has a range of 5 to 7.5 hours, so I'll be using 5 hours to represent the worst case scenario. Finally, click Calculate to reveal the results. For our system, we get a minimum system size of 210 watts and a recommended size of 260. The off-grid calculator also recommends a battery size for both 12 and 24 volt battery banks. Battery information can be obtained by contacting us or staying up with our video series. For a comparison, we can now just change the charge controller type to MPPT by changing the charge controller efficiency value to see how our system would change. For our example, this causes the recommended system size to change from 260 watts to 230 watts. Note that the minimum size did not change since the minimum size does not compensate for charge controller efficiency. Now that you've learned how to use our solar calculators, we invite you to share your questions and comments. Feel free to post your thoughts below. We check our YouTube feed daily and will respond to your questions. We pride ourselves on quality products and service, so if you have any further questions or concerns, please feel free to contact us with our technical support team at 1-800-330-8678.